In today's lesson, I know you'll be glad to hear we won't be covering any new material. It's simply a recap of the methods that we have already covered for solving quadratic equations. Our objectives will be to practice choosing an appropriate method for solving a quadratic equation, and then solve the equation using the chosen method. So let's begin by reviewing the ways we have to solve a quadratic equation. We can factor and set the factors equal to 0. We can use the square root property. We can use the quadratic formula, or we can solve graphically. So let me just give you a problem here and let's start. To get the most out of today's lecture, I highly recommend that if you have an inkling of how to do this problem, that you pause the video, work the problem, then come back to see if you did it the same way I did, or even if you chose another method, did you get the same answers, because that would be okay too. If you're unsure what to do, then you can follow along with me. My method for doing this one would be to ask myself, can it be factored? My first thing I need to look at is the right-hand side equal to 0? That must be the case before I can factor. If that's true, then I'm looking for two numbers that multiply together will give me 10, and the two numbers that pop into my mind are a -2 and a -5. If I multiply those together, I get a +10, and if I add them, I get a -7. Those then are the two numbers that I will use for my factoring, x minus 2 and x minus 5. Remember, then you set each factor equal to 0 and solve, so I get x is equal to 2, and I do the same for the other factor, and I get x is equal to 5. So those are my two solutions. I do want you to realize, though, that sometimes the problems don't look exactly like that last one did, even though they can be factored. When you look at this one, it may not be that factoring is what pops into your mind, but our first step should be to add 10 to both sides. Now it's equal to 0. And then I start asking myself those factoring questions again. Let me point out, this is the problem we just worked, so I'm not going to work it again. Here's the way it looked last time, but I just wanted you to see that they don't always start out looking like this, even though they are factorable. Let's go to another problem now, and let me ask you, what would you do for this one? Choose your method, solve, get your answers, and then come back. If I were choosing a method for doing this one, my method of choice would be the square root property. And let me tell you how I know that. I always choose the square root property when I have no x value in the equation. What I mean by that is I see 3x squared and I see a 15, but I don't see any number attached to an x. When that's the case, my method will be the square root property. In order to use the square root property, I need for this side to be a perfect square. Well, because this is a 3, that is not the case. But I can get rid of that and then proceed. So let's divide both sides by 3, and I get x squared is equal to 5. Now the question I have is this a perfect square? And the answer is yes, it is. X times x is what gives me x squared. So that x is what will be on the left-hand side. And remember, when we apply the square root property, we get plus or minus the square root of the right side. So what I have here now are two answers. You can write them like you have it in the problem, or you can remember that that means you have a positive square root of 5 and a negative square root of 5. But I do want you to see that those really are two separate answers. Let's look at another problem. What if I give you 5x squared plus 7x is equal to -2? If you can, I suggest you pause the video now and continue with this problem. If not, stay with me and I'll take you through a few steps. I would start by adding 2 to both sides of the equation. That would leave me with 5x squared plus 7x plus 2 is equal to 0. I now need you to focus on choosing the appropriate method. Some of you may be able to factor this one. I think it is factorable, and I would suggest that if you can do that, that's fine. But if you look at this one and you say, I don't have a clue how to factor this one, we could use the quadratic formula. It's equal to 0 already, which is a necessity for us to use the quadratic formula, and I want to remind you what your a, b, and c's are. Once you have those, it's simply a matter of plugging things into the quadratic formula. When you plug in, there's what you should have, and then let's simplify. I would have -7 plus or minus the square root of 49 minus 40, all divided by 10. That's -7 plus or minus the square root of 9 divided by 10, -7 plus or minus 3 divided by 10. At this point, you'll want to divide this into the two pieces. The top one will be -7 plus 3 divided by 10, which is negative 4 over 10, and will reduce to negative 2/5. The bottom one is negative 7 minus 3, which is negative 10 divided by 10, and simplifies to a negative 1. So here are your two answers. By the way, you did expect two answers because when you calculated the discriminant right here, you get a positive number. So you know from there on out you're going to get two answers. Let's take another problem now and make another choice. What if I give you one that looks like this? When the left-hand side is a perfect square, this is another opportunity for you to use the property of square roots. The left-hand side will simply be x minus 4, and the right-hand side will be plus or minus the square root of 25. When we simplify, we get x minus 4 is equal to plus or minus 5, and it's time now to break that into the two pieces. X minus 4 is equal to 5, or x minus 4 is equal to negative 5. When you simplify then, you get x is equal to 9, or x is equal to negative 1. If you didn't want to do this one by the principle of square roots, you would have to come back and write this as x minus 4 times x minus 4 is equal to 25. You would then need to FOIL this side over here, and once you've done that, subtract 25 from both sides so that you end up with 0 is equal to whatever this side is. A little bit more complicated, so you really may want to learn how to use the principle of square roots for this one. Let's look at another problem now. What if your problem looked like this? Now this one is a little more complicated. Notice it's not equal to 0. If it were, we could take our two factors and set them equal to 0 and be home free. But it's not equal to 0, so that's not a step we can do. We need to begin by distributing here. That will give us 3x squared plus 14x is equal to 5. Now we can subtract 5 from both sides, and we get 3x squared plus 14x minus 5 is equal to 0. The square root property is not a method I would choose this time because I see that 14x. However, I could use the quadratic formula or factoring. If you're really good at factoring, this one is factorable, but if not, you can always drop back to the quadratic formula. When I plug in my numbers, here's what I get. When I start simplifying, I end up with negative 14 plus or minus the square root of 196 plus 60 divided by 6. Negative 14 plus or minus the square root of 256 divided by 6. Negative 14 plus or minus 16 divided by 6. Once again, you have your two pieces. Negative 14 plus 16 over 6, which will reduce to 1/3, and negative 14 minus 16 over 6, which will simplify to a negative 5. Because this number is positive, I once again am expecting to get two answers, and there they are. By the way, if you wanted to, you could come back up to either of these two lines, enter that one graphically, find your intersections, and you would get these same two answers. Solving graphically can be a really nice way to check your answers if you've worked them out using some other method. Let's look at another problem. Once again, I see no x value, so my chosen method would be to use the square root property. This time I'll look at this side and I ask myself, is that a perfect square? And the answer is yes, it is, because 2x times 2x is equal to 4x squared. So therefore, on the left-hand side, I will get 2x is equal to plus or minus the square root of 75. Let me remind you, if I can simplify this, I need to. Well, do you remember how to do those radicals? 2x is equal to, and we break that down into a radical here that is a perfect square. Well, 25 times 3 is 75, so I can break it down like this, and that would give me 2x is equal to plus or minus 5 times the square root of 3. I'm not quite finished yet because I need x is equal to something. When I divide both sides by 2, I get x is equal to plus or minus 5 times the square root of 3 divided by 2. Let me remind you one more time. You really do have two answers. 5 times the square root of 3 over 2 and negative 5 times the square root of 3 over 2. I hope that you were able to work some of these at least on your own without just following my steps. If not, I suggest you watch this video a few more times until you can look at the problem, identify a method for solving, and then follow through with that method successfully. Let me leave you with my thought for the day. A sense of humor is part of the art of leadership, of getting along with people, and of getting things done. Maintain your sense of humor even during quadratic equations. I'll see you again soon. Bye-bye.